In this video, we'll be looking at a special case of the fundamental theorem of calculus, such that we're looking at what looks like a radical expression in the form of a fractional exponent. So, this rule doesn't change at all. Again, if I'm given this particular example, I'm going to integrate this function. Looking at this thing right here, I must take the antiderivative. Going from 1 to 4, the area under the curve of this object from 1 to 4, I have to go ahead and again anti-differentiate, plug in 4, subtract from that, plugging in 1. So, when I do that, I'm going to go ahead and start that over here, such that I'm looking at x to the power of 3/2 as my function. If I try to take the antiderivative of that, I have to increase the power by 1. Now, when I say I'm increasing the power of this thing by 1, in other words, what I mean is I'm taking that power and I'm adding 1 to it. And then I must divide by that power. Now, this looks like a little bit messier than we want it to be, so I'm going to clean it up. In this case, I will make sure that when I'm combining these fractions, I don't lose the basic skills that we had from algebra, where I find myself a common denominator, and then end up with x to the power of, well, 3 plus 2 is 5, and they're halves. So this is divided by 5/2. Now, one note that you can make about the antiderivative of a fractional exponent is that this fraction in the denominator is not the way we're going to want to leave this. But I do know that I can keep this top stuff as it is. I can flip this into a multiplication. So this 2 on the bottom will flip up to be a multiplication there. So this is 2x to the 5/2 over 5. So that right there is my antiderivative. Again, that's my capital F of x, if this right here is my f of x. Okay, so then right here, if I'm trying to find the integral from 1 to 4 of this function, that means this is going to be equal to the antiderivative function, 5x to the 5/2 divided by 5, evaluated from x equals 1 to 4. Remembering that the fundamental theorem of calculus says I'm going to plug in 4 first, evaluate that. So this is 4 to the power of 5/2 divided by 5 minus, now I'm plugging in 1, 2 times 1 to the power of 5/2 divided by 5. Now I'm going to simplify this. Okay, very carefully. We have to remember that 5/2 power is really just this thing to the power of 5 inside of a square root. However, I can do that in any order I see fit. So I know that 4 in a square root is really 2. So this is 2 to the power of 5 times another 2. That's 2 to the power of 6, all divided by 5. This one over here, I know 1 inside of a square root is 1, and 1 to the power of 5 is 1. So this is simply minus 2/5. Okay. In that case, if I do this very carefully, 2 to the power of 6 is 2, 4, 8, 16, 32. I believe that ends up being 64. Again, one more time. 2, 4, 8, 16, 32, 64, all divided by 5, minus 2 over 5 is then 62 divided by 5. And again, that is the area under the curve of this function from 1 to 4.